Hello, this video is meant to cover PreCalc 2 section on hyperbolas, section 9.2. This video pertains to hyperbolas that are centered at the origin, so at 0, 0. There will be an additional video for those that are translated to a different center. So a hyperbola is one of these conic sections where we cut this plane here, and it's characterized by, we have to find the center, but by the vertexes, the foci, and by these two asymptotes. So we have to, that's kind of the main things about a hyperbola. So when we're drawing hyperbolas, we want to first locate the vertices. We want to draw a rectangle. There's a rectangle in this picture that we drew that goes through the vertices, and it goes through here in this picture. They're calling them the co-vertices, but we want to draw this rectangle, and then we can draw our asymptotes, go through the corners of those rectangles. So in this picture, these black dotted lines are our asymptotes, and then we can draw the hyperbola, and in most cases we're asked to locate the foci, which is important technically for drawing the hyperbola, but for your purposes when you're sketching it, it's not really, we don't usually consider the foci when we're trying to do a rough sketch of it, but it is important and you will be asked to do it. So these are the steps. We locate the vertices, we draw the rectangle, we draw our asymptotes, and we can draw a hyperbola. When we're looking at asymptotes, so our standard equation for a hyperbola is x squared over a squared minus y squared over b squared, or it can be flipped. It can be y squared over a squared minus x squared over b squared equals 1. And so if our x is out front, we have a horizontal transverse axis. So we're going to move from our center, in this case our origin, out to our vertices in the x direction. When our y is in front, we're going to move from our center in the y direction to get our vertices. Okay, so we'll go through two examples, one with a horizontal and one with a vertical. Okay, so horizontal, again, our x is in front and our center is at our origin. So I'm just going to draw our center in here. Now from our origin, we have x squared over 9 minus y squared over 25 equals 1. Okay, so I apologize, the PowerPoint, I haven't figured out how to get nice math equations in these presentations. But this number on our x squared, this 9 is 3 squared, and this 25 is 5 squared. Now these denominators tell us how far we have to move. So from our center, our center in this case is 0, 0, because we just have x squared and y squared. If we had x minus something squared, then we would be shifting from our center. Okay, so our center's at 0, 0. When our x is out front, we're going to move in our x direction, and this denominator tells us how far we're going to move. So we're going to move 3 in each direction. Again, so we go 1, 2, 3, so we get positive 3, 0, 1, 2, 3, negative 3, 0. So our vertex is, our vertices are going to be negative 3, 0, and 3, 0. Okay? Now we want to draw our box. So I'm going to switch colors here. Okay, so our box is going to go through these vertices, but it's also going to go through those co-vertices. So we need to move 5 in our y direction. 1, 2, 3, 4, positive 5, negative 5. So now we can draw a box here like this through our vertices and our co-vertices. And this box helps us draw our asymptotes. So I wonder if I can draw a line. So what I want to do is I want to draw a line that goes through the two corners of my box. So that's going to be one of my asymptotes. I wonder if I can, no. And the other one is going to come, again, through my center and through the corners of this box. Okay, so those are my asymptotes. And I'll go back here to black. So we're going to, when we draw our hyperbola, we're going to go with our vertices and, oops, we're going to go out towards our asymptotes. So we go towards our asymptotes and we never quite touch them. So we're approaching our asymptotes through our vertices. So that's essentially the gist of it. The final thing that we need to do, we need to find the equation of these lines. The equation of these lines, now we went through this box. We went up 5 in our y, so our rise is 5 and our run is 3. We went 3 in our x direction, 5 in our y direction. So the equation for our asymptotes is y is equal to 5/3 x and y is equal to negative 5/3 x. Okay? So you'll notice this 5/3 comes from the denominator of our y and the denominator of our x. It's always going to be that way. And you'll see in some of the standard equations, they usually put like a for the leading term, the positive term, and then you get differences in your formula for your asymptote, but you always are doing your rise over your run. It's always the square root of your y denominator divided by the square root of your x denominator through your center. Okay, let's go ahead and do one that's in the y direction. So this has a vertical transverse axis. So the transverse axis, I didn't mention that. That's a line that goes through our 2 vertices and the center. Okay, so now we have this, back to annotate. We have y squared divided by 16. 16 is 4 squared minus x squared divided by 36, which is 6 squared. And I just wrote it like that. Now again, our center is going to be at the origin at 0, 0. So I usually, when I go through these things, I go ahead and mark them on my graph. Now, my vertices are going to move because my y is positive out front. They're going to move in my y direction, and we're going to move 4 in the y direction. So we're going to go up 4 and down 4 to our vertices. So our vertices are going to be at 0, 4 and 0, negative 4. And if you're mathematical and you like this, usually there's equations. Your center is HK, and if you have a vertical transverse axis, you have your H and your K plus your denominator under your Y and your H, K minus A. If you're an equation person, I'm going to ask when they post this video that they post the equations there. Okay, so we have our center and our vertices, and we need to draw our box. So that's the next step, is we want to draw this box. Now we have to find our co-vertices. So we're going to go 6 in our x direction to get to our co-vertices here and here. And let's draw this box. Draw this box. So usually we draw these dotted lines. I haven't figured out how to do this here. Oops. But this is our box. And now to draw our asymptotes, we're going to draw from the center, come on, from the center through the corners. Okay, and I'm just starting here for each of these. These are going to be our asymptotes. Oh. Okay. So our asymptotes. Now we can draw our hyperbola. So from our vertices, we are going out and approaching our asymptotes, and this vertices here, same deal. Okay. The final thing that we need to do is we need to, so the equations of the asymptotes, we have, again, this is going to be y is equal to, we have our y is 4, our rise is 4, our run is 6x, and we can simplify this as 2/3 x. And then same for the negative. The final thing that we need to find that defines this parabola, or this hyperbola, is our foci. Now our foci is always, we're going to move in the same along our transverse axis. So here this is a vertical transverse axis, and we're going to, our c squared is equal to a squared plus b squared. So in this case, it's equal to 16 plus 36. And 16 plus 36 is 52. So c is equal to the square root of 52, which is 2 square roots of 13. Okay? So we're going to move in our y direction 2 square roots of 13 to get to our foci. So our foci is at 0, 2 square root of 13, and 0, negative 2 square roots of 13. So that is how we draw hyperbolas that are centered at the origin. Like I said, if you're a formula person, I'm going to ask when they post this video that they, in the comments, post a link to all of the formulas, and you can label everything and go from that. I'm graphical, so this works pretty well for me. But if you're formula-based, look for that link that's posted below the video. There will be a second video on translations of hyperbolas, so hyperbolas that are not centered at the origin.